Alright, so in this video we're going to be talking about chemiluminescence. This is a process that's used in some of the analyzers that we talk about in IET 226, our Process Analyzers 2 course at Red Deer College. So the first thing is what I wanted to highlight from the word chemiluminescence is the word luminescence. And what that means is it's often identified as cold light. Cold light being that it's light that's produced without any heat. So another term that kind of means, I guess, almost the opposite of that is incandescence, and it can be thought of as the incandescent light bulb because it's a great example of this. It produces light from heat, so the object gets really, really hot. You can see over here on the bottom right there, I've kind of drawn up a incandescent light bulb. It has a heated wire that gets really, really hot, and then it gives off light. So incandescence is from a hot object, and luminescence is basically produced from a cold object. It doesn't really heat up. So to kind of dive more into the chemiluminescence part, chemiluminescence it produces visible light from a chemical reaction. That's kind of where the name comes from, obviously. Chemi being a chemical reaction, and luminescence means it's giving off light due to that chemical reaction. But remember, there's no heat being produced from this process. So so an example of a reaction that does chemiluminesce, or that luminesces, is the reaction between nitric oxide, which is over here on the left, nitric oxide NO, plus ozone or O3 right here. Those two reactants, they'll react together. If they come close to each other, they'll react, and they'll produce nitrogen dioxide over here and O2 or oxygen. Because this ozone over here, it's really quite unstable and it wants to react, so it'll give off one of its oxygen atoms to form O2, and then it also gives off this light here at the end, and that's actually what that's what the analyzer that we're going to be talking about, that's what it's measuring. The more light being produced means that we have more of these two reactants here. So we can measure the NO there by adding ozone, a whole bunch of ozone, and from our sample, if we put in some nitric oxide, which is a pollutant, if we put that into our analyzer, it's going to produce more and more light once that concentration goes up. So that's kind of our end goal with this reaction, is we were using it to measure the amount of NO there in our sample. And I got an example here. I kind of wrote over it, I see there, but my example here of the same reaction that you'd see in our everyday life is a glow stick. It's got kind of two parts to it. The inside part's made up of some glass that's got a liquid in it, and then the outer part, the glass being right in here, and this outer part here being plastic, flexible, so we can break the glass and the two liquids mix and they give off light. I'm not going to go into the detail of what's in there, but that's the exact same thing that's happening. It's chemiluminescence that's happening there as well. So let's now apply this to the analyzer. We've got a drawing showing how the analyzer works here. It's not too complicated, but without kind of talking about it, it doesn't really make a whole lot of sense. So I wanted to draw up a picture here and kind of show how this thing works. So starting over here at the sample, our sample would flow in, and it can go one of two ways. There's this solenoid right here that's going to switch, and it's going to allow gas to go up to the top and over to the NO2 to NO converter here, or it can just go straight down into our reaction chamber down here. And actually I didn't label that, but that's called the reaction chamber because that's where a reaction occurs. So our sample can come in and go one of two ways with that solenoid there. And then also we need to have this dry air coming in over here. And that dry air right here, it gets converted to our O3 coming in. The ozonator right up here, it's basically like it's got a high voltage potential, and as the dry air flows across it, I don't know if you've ever smelt electricity, but that smell of electricity is the ozone that you're smelling. And the ozonator has a high voltage potential, and it basically takes the O2 that's over here in our dry air and ends up producing O3. And that O3 then wants to react with any of the NO2, any of the NO, just draw that over there, any of the NO that's coming into our reaction chamber down there. And then if it produces light, our photomultiplier tube, our detector down here, senses that and gives us a reading over here on our readout in ppm of NO. So it's always going to be measuring NO. This analyzer can only measure NO, but it can make two measurements here. Let's just see. Yes, NOx and NO. So the way that it makes that NOx measurement that I have right here is, you can see if I kind of color-coded this. So the green has a path that flows up through, and it goes through the NO2 to NO converter. And what's happening there is there's some sort of a heated catalyst that converts any of the NO2 that's coming in to NO. So now we have everything converted to NO. If there's NO2 or NO in the sample, nitrogen dioxide or nitric oxide, if they're both in the sample, any of the nitrogen dioxide gets converted to NO. So coming out of this converter here, it's all going to be NO no matter what of those two compounds. And so what happens there is we're getting a total count. That's what the X over here stands for, is it's the total, both the combined NO and NO2. That's what NOx is. So when we're making our NOx measurement over here, the sample has to be running through that NO2 to NO converter. And then when we're making our NO measurement here, we're taking that other path where you can see in blue how it goes from the sample down directly into the reaction chamber there. And the power of that is we can measure these two different pollutants here. We can measure the amount of NO and nitric oxide and the amount of NO2. So they're both pollutants, and both need to be monitored. So this analyzer can do both by using that switching valve there and switching between the two, and then get the total concentration. By doing some easy math, we can figure out the concentration of NO2, because we kind of have our two scenarios here, where the analyzer will, half the time it will be monitoring with the solenoid energized to allow an NOx measurement to be made, and then the other half the time to measure and make just the NO measurement. And so then on my next slide over here we have the calculation here. I just wanted to show you, manipulated the equation. So if we want to calculate this NO2 value here, the one that we're actually not really measuring, because we are only measuring this value and this value right here, we can then manipulate the equation and solve for the NO2. So in the end, we can figure out that NO2 measurement by using some simple math. So that's what the chemiluminescent analyzer, and that's what chemiluminescence is used for in process analyzers, is to measure for those two pollutants. Basically need to know how that analyzer function and works, because if I was just to go back over here and look at our analyzer here, there's lots of parts here. So the one thing that I didn't point out here, this item right here is a small capillary tube, and it restricts the flow and it controls the flow rate of the sample through the analyzer. So that could plug off, our switching solenoid valve could malfunction. We have our NO2 to NO converter ozonator. There's lots of different parts in this analyzer, so it's important to know kind of how it functions and the purpose of it. So it can be used for both monitoring the ambient air and also for monitoring the concentration of these pollutants in a stack as well. So this technology can be used kind of in both places. But yeah, I would expect it, the chances of things plugging off and stuff go a little bit higher, so you want to be using good filters and stuff so your capillary tubes and stuff won't plug off in this analyzer. So it works well definitely in the ambient air monitoring. The analyzer that we have in the lab can go down to the part per billion range, so it's quite sensitive. So hopefully that makes sense. I wanted to kind of do a quick little video on how this thing works to kind of supplement the PowerPoint slides. So hopefully that makes sense there on how the chemiluminescent analyzer functions.